Okay, part E probably seems the most intimidating because now I suddenly have these like trick functions, right? But it's actually, I think it's calculationally easier than some of the previous examples. It's just that you need to remember the formulas for the derivatives of trig functions. So just a reminder, the derivative of tangent of something, so tangent of x, for example, is secant squared x, sec squared x, like that. And then the derivative of secant of something, for example, x, is secant x tangent x. Or in the other way, doesn't matter what the order is, okay? So I need to remember these two for the exam as well. And from here, we are given the function f of x equals tangent of x squared plus 2 plus secant of minus x cubed plus x squared. Now, whenever you have a plus, you know that the derivative could be split into two, right? So the derivative of this whole thing, let me just duplicate it, is equal to the sum of the two separate derivatives, okay? So I could rewrite it as tangent of x squared plus 2 derivative plus the derivative of secant of minus x cubed plus x squared, like that, okay? And now we can just calculate them separately. I'll actually do that separately, you know what? I'm gonna write them. Let's start with the tangent one. Now, once again, if we just had tangent of x, okay, if we just had tangent of x, then it would have been directly secant squared x and we're done. But notice how inside of the tangent function I have another function. It's not just x, it's a whole function. It's x squared plus 2. So that's once again the chain rule, where the outer, let me just write it the way I wrote it in the previous problems. The outer function is tangent of something, and the inner function is x squared plus 2. Why inner? Because that's the inside, and then then the inside you plug into the outside, right? It's just visually inner and outer. I don't know how else to explain it. But these are the two functions. So now in order to find the derivative, we need firstly the derivative of the outer function with the inner function unchanged inside. So derivative of tangent is always secant squared, as I told you. So that's going to be secant squared of whatever's inside of it without changing it. So that inner expression, for now, I'm not going to touch it inside of the secant squared, okay? So it's going to be just x squared plus 2. But now we need to multiply by the derivative of the inner function. So derivative of x squared plus 2 is going to be just 2x. And now I can just rearrange, but I'm basically done with this particular derivative, okay? 2x secant squared x squared plus 2, and we're done. But don't forget that this is only the first part. Now we need to calculate the second part. So that's secant of minus x cubed plus x squared derivative. Once again, we have an inner function, so inner function is minus x cubed plus x2, and then this we plug into an outer function, which is secant of that whole thing, okay? So how do we start calculating the derivative? We start by calculating the derivative of the outer function. So derivative of secant is equal to secant tangent. That's just how the formula goes, right? So it's going to be secant of whatever the inner function is with unchanged. We don't change it for now, right? We just copy the original, and we only apply the we copy the inner function for now, and we only apply the derivative to the outer function. So that's going to be secant of minus x cubed plus x squared times tangent of minus x cubed plus x squared. That's the derivative of the outer function. And only now do I take the derivative of the inner function and I multiply. So that's gonna be minus 3x squared plus, let me just show you, that's a 2 here. So it's plus 2x, okay? And I can just leave it at that. So now for the derivative of f, like the final value, what do we have? So we found the derivative of the green part, right? And then we also found the derivative of the blue part, like that. So we just need to sum them, okay? So I'm gonna copy this one first. It's 2x secant squared of x squared plus 2. And now I add whatever the blue part here is. This is a long one, but it's, I'm just gonna copy this way. Secant of minus x cubed plus x squared times tangent of minus x cubed plus x squared times minus 3x squared plus 2x. Now, I typically prefer having the algebraic expressions before the trigonometric ones, but you don't have to do it this way. You could move this in front, you could keep it like I have, it's fine. That's our final answer to part E.